Okay, so today we're going to cover the second day of section 6. It's 1.6b. Today we're going to learn how to solve other types of equations and solve radical equations. So our first step is always going to be to isolate the square root. Then you're going to square both sides of the equation and then solve what remains. You must check all of your answers when you start out with a radical equation with a square root. So let's look at our first example. So again, step number 1 is to isolate the radical. Okay, so I'm going to isolate the square term, the radical, sorry. Now, what's going to be better for me, instead of moving the x and leaving the negative square root of 16 minus 2x, I'm going to move the radical to the other side so it becomes positive. So I'm going to add this to both sides because we always have to isolate the radical first. So now I'm left with x is equal to 15 minus 2x, and it's all under the square root. Second step, square both sides to eliminate the radical. So I'm going to square this side and this side. The right side, squaring that radical makes it disappear. And now I'm left with x squared equals 15 minus 2x. I need to get this quadratic equation into standard form so I can solve it. So I'm going to subtract, or I'll add the 2x first. The order that you move the 15 and the 2x doesn't matter. And then I'm going to subtract the 15. And now I'm left with x squared plus 2x minus 15 equals 0. Now I have a quadratic equation that I need to solve. At this point, you can choose. You can factor it, you can use quadratic formula, or you can use completing the square. Honestly, factoring is the fastest, so I'm actually going to factor this one. So I'm going to go ahead and move over here to the side. I'm going to go ahead and rewrite it up here so I have plenty of room. So my factors of negative 15 that give me positive 2 are going to be positive 5 and negative 3. I then set each of my factors equal to 0. X minus 3 equals 0. Subtract 5. X equals negative 5. Add 3. And x equals positive 3. Now, whenever you start out with a square root in your original problem, we need to check to make sure that our answers work. So what I'm going to do now is my check, which is mandatory. I'm going to go ahead and plug in negative 5 and positive 3 into the original equation. So x minus 15 minus 2x under the radical equals 0. I have to do this twice. Let me go ahead and get this set up here. So I'm going to replace x with negative 5 on this one. Going to follow order of operations and simplify everything here. So 15 plus 10. 15 plus 10 gives me 25. And negative 5, and then the square root of 25 is 5. Negative 5 minus 5 is negative 10. It does not equal 0. So negative 5 is not a good answer. Now let me plug in the positive 3. So I'll plug in 3 now for each of my x's here. 15 minus 2 times 3 under the radical. 15 minus negative 2 times 3 is negative 6. 15 minus 6 is going to give me 9. And then when I square root the 9, I get 3. 0 equals 0. This is a good answer. So the answer to this problem is x equals 3. So when 1 works, the answer is not no solution. You just get rid of whichever solution doesn't work. Now, as soon as you get 1 to fail, don't automatically assume the other one is going to work. You have to check them both. They both could fail or they both could work. So you have to check everything. Let's try number 2. Same thing. I'm going to isolate the radical first. Doesn't matter which side it's isolated on. So again, I'm going to move this to the other side by adding it. And this radical shouldn't be under the 0. It should have stopped. But the square root of 0 is just 0. So plus this to the side as well. So now I have x is equal to the square root of 3x plus 18. Again, my next step will be to raise both sides to the power of the index, and this index is a square root, so I square both sides. If it were a cube root, and we're going to see that coming up, we would cube both sides. But here, it's going to cancel out the radical. So now I'm left with x squared equals 3x plus 18. I need to get it into standard form. So I'm going to subtract the 3x. X squared minus 3x equals 18. Subtract the 18. And now I have a quadratic equation in standard form that I can solve either by factoring if it's factorable, quadratic formula, or completing the square. This is factorable, and I'm going to factor it because for me, factoring is the fastest way. So I'm going to come on over here, rewrite the problem. Factors of negative 18 that give me negative 3 are going to be x minus 6 and x plus 3. Set each of your factors equal to 0. Solve for x. This one I'm going to add 6. Subtract 3 on this one. So my two potential solutions are positive 6 and negative 3. Again, I need to check both. So I'm going to plug back in the positive 6 first. So x minus 3x plus 18 equals 0. Every place I see an x, I'm going to put the 6. Going to follow order of operations underneath the radical. I get 18 plus 18, which gives me 36. The square root of 36 is 6. And 6 minus 6 is 0. So this one's good. So far I got a good answer here with x equals 6. Now let me try the negative 3. So again, I'm plugging it into this original equation. So I'm getting negative 3 minus 3 times negative 3 plus 18 equals 0. Negative 3 minus negative 9 plus 18 under the radical. Negative 3 minus the square root of 9. The square root of 9 is 3. Negative 3 minus 3 is negative 6. This does not equal 0, so x equals negative 3 is a bad answer. Now, you may start seeing a pattern here that the negatives aren't working. You can't assume that. You have to check because negatives will work. And once we get to number 4, we're going to see that a negative number will work. So let's go ahead and try number 3. Again, this one's already isolated for me. So all I need to do is square both sides. Let me just go ahead and rewrite it here. So I have 4x plus 13 equals 2x minus 1. Again, I'm going to square both sides. The right side, I need to FOIL that thing. So the left side, the 4x plus 13 just comes out because the squaring the radical canceled it. But now what I need to do here is 2x minus 1 times 2x minus 1. Once I FOIL that, I end up with 4x squared minus 4x plus 1. I now need to get this into standard form. I want to keep my x squared term positive. So I'm going to move the 4x over and the 13 over. Subtract the 13 now. And now I'm left with 0 equals 4x squared minus 8x minus 12. Let me go ahead and just flip it around. Now, at this point, you can either factor it, quadratic formula, completing the square. I notice that all three terms have a GCF. I'm going to divide them all by 4. So 4, and then I'm left with x squared minus 2x minus 3 equals 0. Now I have a nice, easy trinomial that I can factor. Factors a negative 3 that give me negative 2. It's going to be negative 3 and positive 1. I now set each one of my factors equal to 0. So I'm even setting the GCF equal to 0, but notice my GCF doesn't have a variable to solve for, so there's nothing to do here. But I can solve the other two, so I'll add 3, x equals 3, subtract 1, and x equals negative 1. Again, I need to check both. So I'll go over here to the side now, and I'll do the check. So for the first one, again, you're going to take your original problem, the 4x plus 13 equals 2x minus 1. I'm going to first plug in the positive 3 for both x's. I get 12 plus 13, 6 minus 1. 12 plus 13 is 25. The square root of 25 is 5. X equals 3 is a good answer. Now let's plug in the negative 1. So same thing. Take the same original equation here, and I'm plugging in negative 1 for each of the x's. So 4 times negative 1 plus 13 equals 2 times negative 1 minus 1. So negative 4 plus 13 equals negative 2 minus 1. Negative 4 plus 13 is 9. Negative 2 minus 1 is negative 3. The square root of 9 is 3. 3 does not equal negative 3. So x equals negative 1 is a bad answer. So I only have one solution here. The next one, again, same thing. Isolate the radical first. So on this one, and let me go ahead and just move it on down here so I don't get into that other problem. So 6x plus 7 minus 1 equals x plus 1. Isolate the radical first. So what I'm going to do is add 1 to both sides. My 6x plus 7 that's under this square root is now isolated. So now I can square both sides. Once I square the right side, I got to FOIL it. The left side, it just comes out because that squaring that radical makes it disappear. So what I'm doing here is multiplying x plus 2 times x plus 2. Once I FOIL it, I'm left with x squared plus 4x plus 4. I need to get it into standard form. Always try to keep your x squared term positive. So I'm going to move the 6x and the 7 to the other side. X squared minus 2x plus 4. Subtract the 7. 0 equals x squared minus 2x minus 3. And if you notice, this is the same trinomial that we just factored on the previous problem. So this factors into, it was just a coincidence, x minus 3, x plus 1. I'm going to go ahead and solve each one by setting it equal to 0. add 3. First potential answer is x equals 3. And the second one is x equals -1. I have to do the check now. So I'm going to check both of them. So again, the question I'm plugging it into is the original. So first I'll plug in the positive 3. So 6 times 3 plus 7 minus 1 equals 3 plus 1. 18 plus 7. And this is all under the radical. And this gives me 25. The square root of 25 is 5. 5 minus 1 is 4. 4 equals 4, it checks. X equals 3 is good. Now let's do the -1. So again, same question here. 6 times -1 plus 7 minus 1 equals -1 plus 1. -6 plus 7 minus 1 equals 0. -1 plus 1. The square root of 1 is 1. 1 minus 1 is 0. 0 equals 0. I finally have a negative answer that works. So this one actually has 2 solutions. So again, don't automatically assume that the negatives don't work. You have to check everything. So for number 5, again, you need to isolate the radical first. So what I'm going to do is add x plus 1, the square root of it, to both sides. So now I'm left with 2x plus 3 under the radical equals 1 plus x plus 1 under the radical. Now, in order to get the radical to disappear, we have to square both sides. But notice this right side, I'm squaring. I got to FOIL that thing. I can't just apply the exponent to both. So the left side, the 2x plus 3 just comes out. However, this right side, and let me show you the FOIL process, because it's a little bit more challenging than just a normal FOIL. So I'm writing it twice, and I'm FOILing this. So I'm doing first, 1 times 1 is 1. Then I'm doing the outer, and I get 1 square root x plus 1. Then I do the inside, and I get 1 x times x plus 1 under the radical. But then when I do the last, when you multiply a radical by a radical, it's just going to come out. So then the x plus 1 comes out on this. I need to combine my like terms. So this middle part can be combined. This is actually going to give me, also when I combine the constants here, this 1 and this 1 at the end give me 2. Then the middle becomes 2 times the square root of x plus 1. And then I just have the plus x. So this is my FOILed answer. So let me go ahead and put that over here. So now I have 2 plus 2 times the square root of x plus 1 plus x. So now I still got a radical in my problem. I got to isolate the square root of x plus 1. I got to move all of this to the other side. So let me work on doing that. Doesn't matter what order you move things. So I can go ahead and move the x first. So I could subtract x. And then I get x plus 3 equals 2 times the square root of x plus 1. Then the next thing I can move is my constant. So I could subtract 2 from both sides. And then I get x plus 1 equals 2 times the square root of x plus 1. All right, I'm just going to leave the 2 in front of that radical. And now I'm going to square both sides. So So now notice this, it's not got a plus or minus sign, so I'm not foiling. All I'm doing is I could square the 2, and then the x plus 1 comes out. Over here, though, I got to foil this thing. And once I foil that, I get x squared plus 2x plus 1. I have to distribute this 4, and this becomes 4x plus 4. This blue one stayed the same for right now. And now I need to get it in standard form. So I need to subtract the 4x. And I get x squared minus 2x plus 1. Move the 4. And now I have a quadratic equation that I can either factor, quadratic formula, or complete the square. Again, this is nice and easy to factor. Factors a -3 that give me -2, -3, and +1. So these problems are going to get very, very long. So here, set each of these equal to 0. So x minus 3 equals 0. X plus 1 equals 0. I'm going to add 3. X equals +3. Subtract 1. And now I have to do the check. So let me go ahead and plug both numbers in. And again, the equation I'm plugging them into is the square root of 2x plus 3 minus the square root of x plus 1 equals 1. So I'm going to plug in 3 first. So 2 times 3 plus 3 minus 3 plus 1 equals 1. 6 plus 3, 3 plus 1. 6 plus 3 is 9. Square root 9, square root 4, 3 minus 2 is 1, 1 equals 1, good answer. So x equals 3 is a good answer. Now let's plug in the -1. So again, we're replacing all the x's with a -1 this time. -2 plus 3. -1 plus 1 is 0. -2 plus 3 is 1. The square root of 0 is just 0. And then the square root of 1 is 1. 1 minus 0 equals 1. 1 equals 1. Good answer. So x equals -1 is also a good answer. So for number 6, again, we've got double radicals here, so we're going to have to do the elimination process twice of the squaring both sides. So again, move one of the radicals to the other side because we got to eliminate one radical at a time by isolating it. So now I'm left with 2x minus 5 all by itself, and then we have the 1 plus x minus 3. So again, I need to square both sides. When I square the left side, that one cancels. However, the right side, I got to foil it again. So again, if you don't know the pattern or you're struggling with this, write it down 2 times. Take your time. Do first, outer, inner, last, so you don't mess up when you're foiling this. So once I do first, 1 times 1 is 1. The outside gives me 1 times the square root of x minus 3. You don't have to put the 1 in front, but it helps me to remember when I combine those like radicals that I'm going to add 1 plus 1, and I get 2 times the square root of x minus 3. And then finally, last, the radical just disappears here. I now need to combine my like terms. So the 2 middle ones will combine, and this will become 2 times the square root of x minus 3. And then I have a constant 1 and a -3 that I can combine. And that'll give me a -2. And then I also have just the single x here. Okay, so now that is what is left over here. And now I need to isolate this radical here. So I'm going to go ahead and add 2. And then I'm left with 2x minus 3 equals 2 times the square root of x minus 3. Then I can move my x. And now I'm left with x minus 3 is equal to 2 times the square root of x minus 3. I'm now going to square both sides. The right side becomes 4 times x minus 3. The radical disappears. However, I need to FOIL the left side. This will FOIL into x squared minus 6x plus 9. I'm going to distribute the 4. And then now I need to get it in standard form. So I'm going to subtract 4x. And I get x squared minus 10x plus 9 equals -12. And now I need to move the 12 over. And I get x squared minus 10x plus 21. And now I can either factor it or do quadratic formula or completing the square. When it's these easy trinomials, I'm going to factor it if it's factorable. And the factors of positive 21 that are going to give me a -10 are going to be -3 and -7. I now need to set each of these equal to 0. Add 3. X equals positive 3. X equals positive 7. I now need to do the check for both. So again, the equation I'm plugging it into is 2x minus 5 under the radical minus the square root of x minus 3 equals 1. I'll plug in 3 first. Six minus 5. 3 minus 3 is 0. 6 minus 5 is 1. Square root of 0 is 0. Square root of 1 is 1. 1 minus 0 is 1. 1 equals 1. I got a good answer here at x equals 3. And now let me do the next check. So again, I'm going to plug in positive 7 now. So 2 times 7 minus 5. And then 7 minus 3 equals 1. 14 minus 5. Square root of 4. 9. Square root of the 4, I get a 2. Square root of the 9, I get a 3. 1 equals 1. It checks. X equals 7 is also a good answer. So on Monday, I will continue with the last of the examples. You have a homework assignment, however, it's not due until Tuesday.